press the bell icon on the YouTube app and never miss another update.
Namaste children. So in the previous class we discussed about the structure of neurons and types of neurons and also types of neuroglial cells. In this class we will discuss about how the impulse is generated and how it is transferred to the other neurons, how impulse is generated and conducted along the nerve fiber. So the nervous tissue, that tissue which translates sensory information into action potential, that will bring response in the effector organs, that shows actions in the effector organs. That means nervous tissue is going to translate sensory information into action potential. That is nothing but nerve impulse. This impulse, when it reaches the effector organs where we see the actions. So in the generation and conduction of nerve impulse, we have three steps. One is polarization or resting state polarization or resting state in neuron. Another one is depolarization or conduction of action potential along the axon. So another one is repolarization. Or restoring resting state of neuron or restoring resting state of neuron. Understood? So here, so this we know that this is axon, cell body, so what I am writing here, it is axon part. This part I am writing. So ಇಲ್ಲಿ ಏನು axon part ಇದೆ ಅದನ್ನು ನಾನು ಇಲ್ಲಿ ಬರೀತಾ ಇದ್ದೀನಿ. Understood? So when neurons are at rest, we see negative charges inside and the neural axonema is having See, when neurons are excitable cells because their membrane will be in a polarized state. What is polarized state? Andre, the membrane, one side it will having positive charge, another side it will have negative charge. The type of membrane is called polarized membrane. So resting neuron andre yavadu stimulus illa andre that neuron is called resting neuron. When neurons are at rest, outside the axon, that is in extracellular fluid, outside the axon andre extracellular fluid alli we see sodium ion concentration will be more. Again inside the axon we see potassium ion concentration will be more. Inside we see potassium ion concentration more, where outside, so outside we see, outside the axon we see more sodium ion concentration, and inside we see more potassium ion concentration. So at rest the axolemma means the plasma membrane which covers the axon is permeable to, points ನೆನಪು ಮಾಡ್ಕೊಳ್ಳಿ, at rest axolemma or neurolemma is nothing but plasma membrane of nerve fiber is permeable to potassium ions, and it is impermeable to sodium ions and negatively charged protein molecules or protein molecules. So nodi, when the neurons are rest, outside the axoplasm or in the extracellular fluid we see more sodium ions, and inside the cytoplasm of axon we see more amount of potassium ions. So ionic gradient irodrinda enagutte, they move from the higher concentration to lower concentration, but this membrane is permeable to potassium ions only. Hagagi enagutte illi potassium moves out of the axoplasm. Axoplasm olgade potassium will move to the extracellular fluid because this membrane is permeable to potassium ions and sodium impermeable to sodium ions. So hagagi as it is impermeable, as it does not allow the sodium ions to enter into the axoplasm, so this results in outside positive charges and inside negative charges. Inside the axoplasm we see large size negatively charged protein molecules, and that negatively charged protein molecules cannot go out to the extracellular fluid. Hagagi enagutte, inside we see negative charge and outside we see positive charge. So and idru jotege other one will help to maintain this polarized state, that is sodium potassium pump. Sodium potassium pump, it is an active transport. It is a competitive nenpidkobek, it is a active transport. So in which it sends 3 sodium outside and for 2 potassium inside. 3 sodium outside and 2 potassium inside. Nodi, resting, when neurons are rest, we see active transport of sodium potassium pump. Nodi, passive diffusion agutte. As the membrane is permeable to potassium ions, they move from their higher to lower concentration. Avaga namage we does not require any energy. Understood? Higher to lower ಹೋಗುವಾಗ it is not required energy. But in sodium potassium ಪಂಪಲ್ಲಿ ಏನಾಗುತ್ತೆ 3 sodium will move outside. They are moving. Sodium extracellular fluid ಅಲ್ಲಿ ಜಾಸ್ತಿ ಇದೆ, ಆದರೆ ಇಲ್ಲಿ ಕಮ್ಮಿ ಇದೆ. ಅದರ ಜೊತೆಗೆ there are 3 sodium ions will move out to the extracellular fluid from the exoplasm. In turn, 2 potassium ions will enter again from its lower to higher concentration. ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ, when they move from lower to higher, they require energy. That's why it is active transport. That means it requires energy. So this all helps to maintain negative charge inside and outside, positive charge when neurons are at rest. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, when neurons are at rest, we see negative charge inside and positive charge outside the axolemma. This is because the axolemma is impermeable to sodium ions and negatively charged molecules. ಹಾಗಾಗಿ negative charge ಹೊರಗಡೆ ಹೋಗಲ್ಲ, ಹಾಗಾಗಿ sodium will not enter into the exoplasm. With that, the membrane is permeable to potassium ions. Most of the potassium ions move out of the move out from the exoplasm to extracellular fluid. ಇದರ ಜೊತೆಗೇನೆ sodium potassium pump will help to maintain this polarized state by sending 3 sodium ions outside, and in turn it will take 2 potassium into the exoplasm. So all these conditions helps to maintain negative charge inside the axolemma and positive charge outside the axolemma. This state is the polarized state of neuron. This is polarized state of neuron, and the potential difference between this membrane is called resting potential. Resting membrane potential or resting potential. Resting membrane potential or resting potential is nearly minus 70 millivolt. How they are going to calculate ಅಂದ್ರೆ electrode na ಒಂದು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ಗೆ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾರೆ, ದಿಸ್ ಇಸ್ ವೋಲ್ಟ್ ಮೀಟರ್, ಒಂದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜಿಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿ ಮೆಷರ್ ಮಾಡ್ತಾರೆ, that we get minus 70 millivolts. So this is the condition where we see polarized state when neurons are at rest. Next, depolarization. So when this occurs, see sodium, these neurons are also have voltage gated channels. Voltage gated channels, that means they are going to open when there is potential difference seen across the membrane. These voltage gated channels will be closed when neurons are at rest. There are 2 voltage gated channels, one the sodium voltage gated channel, another one is potassium voltage gated channel. These 2 are also closed, nodi close agide when neurons are at rest. So now depolarization. See, when when we apply stimulus, stimulus may be either mechanical, chemical or physical. Physical like heat or cold, chemical like bases, acids and bases, mechanical like injury. When we apply stimulus, we see change in the polarized state. Change in the polarized state, that means we see, nodi, when neurons are at rest, rest alli iddaga enagittu, outside positive ittu, inside negative ittu. Yavaga now stimulus apply martivi, there we see changes in their polarity, because when stimulus is applied, the membrane axolemma will, what it will do, so the sodium voltage gated channels will be opened when we apply stimulus, so that results in rapid influx of sodium into the axoplasm from the extracellular fluid. Now yavaga stimulus apply martivi, excited region, neurons are going to become excited, so that makes the opening of sodium voltage gated channels. Then the sodium moves from extracellular fluid into the axoplasm. This rapid inward movement of sodium results in reverse of polarity. That means inside we see positive charge, outside we see negative charge. That state is called depolarized state, and the potential difference which develops in the depolarized state is called action potential. That is called action potential, is nothing but nerve impulse. It's nothing but nerve impulse. ಆಯ್ತಾ ನೋಡಿ, ಯಾವಾಗ ನಾವು ಸ್ಟಿಮ್ಯುಲಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ, ರೆಸ್ಟಿಂಗ್ ಸ್ಟೇಟಲ್ಲಿ ಸೋಡಿಯಂ ವೋಲ್ಟೇಜ್ ಗೇಟೆಡ್ ಚಾನಲ್ಸ್ ಕ್ಲೋಸ್ ಆಗಿರುತ್ತೆ. ಯಾವಾಗ ನಾವು ಸ್ಟಿಮ್ಯುಲಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ, ದೇರ್ ವಿ ಸಿ ಓಪನಿಂಗ್ ಆಫ್ ಸೋಡಿಯಂ ವೋಲ್ಟೇಜ್ ಗೇಟೆಡ್ ಚಾನಲ್ಸ್, that results in inward movement of sodium ions into the axoplasm. So yeah, as it moves inside, we see reversal in polarity. That means inside we see positive charge, outside we see negative charge. This allows the development of mini electrical circuit. That means current with adjacent to the excited region. So this action potential is developed only in a localized area. Elli stimulus apply madirthivi allasthe we see the change in the ions, not on whole axon. Action potential is going to develop in a very small area or localized area only where stimulus is applied. Change in electrical charges we see only in the area where stimulus is applied. Adjacent nerve fiber will be in resting state. This all in again resting state. This part will be in polarized state. Only this part where we applied it will be in depolarized state. It will be in depolarized state. Remaining R will be in polarized state. ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ, in polarized state, inside we see negative charge, outside we see positive charge. So this develops mini electrical circuit. That means current flows from A to B inside and again B to A outside. Mini electrical circuit is going to develop between the depolarized state and polarized state. After this circuit completes, sodium voltage gated channels will be closed and rapid efflux of potassium takes place. Before going to next stage, nodi, resting neuron alli we see inner negative charge, outside positive charge. Yakendre membrane axolemma is permeable to potassium ions and impermeable to sodium ions and negatively charged protein molecules. But the voltage gated channels, both sodium and potassium will be closed. ಯಾವಾಗ ನಾವು ಸ್ಟಿಮ್ಯುಲಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ, where in that excited region, we see the opening of sodium voltage gated channels that results in influx of sodium into the exoplasm that makes reversal of polarity, and the outside will become negative, inner will become positive, and that is seen in a localized area, only a part of axon. The remaining axon will be at a resting state or it will be in a polarized state. ಅವಾಗ ಏನಾಗುತ್ತೆ, the electric circuit will develop from A to B, that means from depolarized state to the polarized state, again from polarized to depolarized state. So when the circuit completes, the stimulus will shift to next region, that is B region. So that we will discuss now. So once the circuit completes here, the stimulus will shift to the next region. So next region its stimulus shift ಆಗ್ತಿದ್ದಂಕಲೆ in the B part again we see reversal of polarity. Sodium gated channels ಏನಾಗುತ್ತೆ open ಆಗುತ್ತೆ and sodium will move into the exoplasm. Again we see inside positive charge, outside negative charge. Adjacent to B, again that neuron will be in resting state. Again the circuit from here B to C, then again from C to B. Matte illi one mini electrical circuit develop agutte. Illi this region which is stimulated first, that will be in repolarized state. Yavaga stimulus adjacent area shift ಆಗ್ತಿದ್ದಂಕಲೆ this area will become repolarized. That means sodium voltage gated channels will be closed and potassium voltage gated channels will be opened. Hagagi efflux of potassium takes place. That means potassium will move out of the exoplasm, again restoring negative charge inside and positive charge outside. That state is called repolarized state. And adjacent area nodi, now it is in depolarized state. adjacent to that again it is in polarized state. ಇದೇ ರೀತಿ that stimulus information will be transferred from one part of the axon to the adjacent till it reaches the axon terminal. Till it reaches the axon terminal. So once again I will explain this. See, when neurons are at rest, the inner charge inside the exoplasm we see negative charge, outside we see positive charge. This occurred mainly due to the new axolemma is permeable to potassium ions and it is impermeable to sodium and negatively charged protein molecules. ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ, sodium cannot enter into the cell, it will remain outside in extracellular fluid, whereas potassium can easily move out of the cell because the membrane is permeable. This helps to maintain negative charge inside and positive charge outside. Idr jotege sodium potassium pump, which is an active transport, also helps. That transfers 3 sodium outside and 2 potassium inside. ಈ ಎಲ್ಲದನ್ನು ಏನು ಮಾಡುತ್ತೆ, helps to maintain negative charge inside and positive charge outside. So the potential difference across this resting neural membrane is called resting membrane potential or resting potential. It will be 70 millivolt. ಯಾವಾಗ ನಾವು stimulus apply ಮಾಡ್ತೀವಿ, in that localized region we see reversal of polarity, that's depolarization will take place by opening of sodium voltage gated channels. Resting time alli eradu close agirutte, but stimulus apply maddaga we see only opening of sodium gated channels. That makes influx of sodium ions into the exoplasm. Rapid influx of sodium ions into the exoplasm makes to develop positive charge inside and negative charge outside. This condition is called depolarized state. This state is called depolarized state, and adjacent to that nerve fiber will be, again it will be in a polarized state. The potential difference across this depolarized membrane is called action potential, that will be plus 30 millivolts to plus 45 millivolts. So then mini electric circuit will develop between positive to negative from A to B region, that means from depolarized state to polarized state, again from polarized state to depolarized state. Mini electrical current flow circuit complete ಆಗ್ತಿದ್ದಂಕಲೆ the stimulus will shift to adjacent nerve fiber. It will shift to adjacent area of the nerve fiber. So e area ಏನಾಗುತ್ತೆ, previous to that will become repolarized state. So when it shifts to adjacent, B ಗೆ shift ಆಗ್ತಿದ್ದಂಕಲೆ in that again we see opening of sodium gated channels. ಇಲ್ಲಿ repolarized state ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, we see opening of potassium gated channels. ಹಾಗಾಗಿ efflux of potassium takes place in the repolarized state. ಅವಾಗ as positive ions move out of the exoplasm, again that helps to maintain inner negative charge, outer positive charge, restoring resting membrane, resting potential back here in the repolarized state by opening of potassium voltage gated channels. So this part again will be in a repolarized state. Elli stimulus shift agutte, that will be in a depolarized state. Now B is in a depolarized state. Once again your circuit completes, it shifts to next region and next region, like that it will till it reaches the nerve endings, till it reaches the nerve endings. So in the next class we will discuss how information will be transferred from these nerve endings to the next neuron. So that we will discuss in the next class. ಸೊ ಇದು ನೀವು ಎಕ್ಸಾಮ್ಗೆ 5 ಮಾರ್ಕ್ಸಿಗೆ ಕೇಳಿದಾಗ ನೀವೇನು ಮಾಡ್ತೀರಾ, ಯು ಶುಡ್ ಡ್ರಾ ದಿಸ್ ಡಯಾಗ್ರಾಮ್ and you have to explain. So ಇದು ಹಾಕಿ and this also you have to draw. ಕೆಳಗಡೆ ಏನು ಡಯಾಗ್ರಾಮ್ ಹಾಕಿದ್ನಲ್ಲ ಅದು ಕೂಡ ಹಾಕಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕಾಗುತ್ತೆ ನೀವು. ಸರ್ ಈಸಿಯಾಗಿ ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದಕ್ಕೆ ನಾನು ನಿಮ್ಗೆ ಏನು ಮಾಡ್ತೀನಿ ಅಂದರೆ ಶೋಯಿಂಗ್ ಟೇಬಲ್. ಸೊ ಪೋಲರೈಸ್ ಸ್ಟೇಟಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ವಿ ಸಿ ದ್ಯಾಟ್ we see outer positive charge this will be sodium voltage gated channels, this will be potassium voltage gated channels, and inner we see negative charge. Sodium, potassium, come. So in the polarized state, when neurons are at rest, sodium potassium pump will be open. ಏನಾಗುತ್ತಿಲ್ಲಿ it is an active transport. So what happens here? It will be seen 3 sodium ions will move outside and 2 potassium ions will move inside exoplasm. 3 sodium ions will move outside, 2 potassium ions will come inside, and passive diffusion. Passive diffusion is also seen in, what is passive diffusion? Ions will move from their higher to lower concentration. As the neurilemma or axolemma is permeable to potassium ions, the potassium ions will move from inner to outer, because potassium concentration will be more inside compared to outside. That also occur. But illi active transport alli it moves from its lower to higher, but bare time alli it moves from its higher to lower. That is seen. And here sodium voltage gated channel will be closed. Not seen. And potassium voltage gated channels will also be closed. Also closed. And potential difference. That potential difference is called resting potential. That is minus 70 millivolt. So this happens when neurons are at rest. ನಿಮಗೆ ಪಾಯಿಂಟ್ಸ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಅಂತ ಕಾಂಪಿಟೇಟಿವ್ಗೆ. when neurons are at rest, when they are in polarized state, we see inner negative charge, outside positive charge. So, yeah, because the membrane is permeable to potassium ions, hagagi potassium will move out of the cell, that is passive diffusion occurs for potassium, not for sodium and negatively charged ions. The membrane is impermeable to sodium and negatively charged ions. ಅದರ ಜೊತೆಗೆ sodium potassium pump also takes place. It is an active transport. It requires ATP molecules. For this, 3 sodium move outside the exoplasm and 2 potassium enters into the cell, and sodium and potassium gated channels will be closed. They are closed, and the potential difference developed across this membrane is called resting membrane potential or resting potential. It is minus 70 millivolts. So, depolarized state alli enagutte. So, we see opening of sodium ions, sodium voltage gated channels, ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಡಯಾಗ್ರಾಮಲ್ಲಿ ಇದೆಲ್ಲ ತೋರಿಸಿಲ್ಲ, ನೀವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಡಯಾಗ್ರಾಮ್ ಹಾಕಿ ಕೂಡ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೋದು. ಸೊ there sodium is opened. So this results in development of positive charges inside and negative charges outside. So, in depolarized state there is sodium potassium pump function iralla, passive diffusion irutte. Sodium is opened, potassium is not opened, it is closed, and the potential difference developed in the depolarized state is called action potential. It will be of plus 30 millivolt to 45 millivolt. So, that happens in the depolarized, when neurons are depolarized. Again, repolarized means, again we see negative charges inside and positive charges outside. So, in the repolarized state we see opening of potassium voltage gated channels. ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ, potassium moves outside the exoplasm and sodium gated channels will be closed. Sodium gated channels will be closed. So, this potassium, again this passive diffusion occurs. So, this is now potassium will be closed and will be opened. So, this happens when repolarization takes place. What happens in repolarization? Passive diffusion irutte. Sodium potassium pump is in only in the resting state alli. Again, yes, this also opens and sodium gated channels will be closed, potassium gated channels will be opened. So, that neuron will be in a repolarized state. So, this itara table hakonde you can remember these points in your competitive exams. Competitively idu tumba keltare. Sodium potassium pump, it is a passive transport or active transport anta keltare. It is a active transport. Yake adu active transport? It requires energy because sodium moves from its lower to higher concentration. 3 sodium ಹೊರಗಡೆ ಹೋಗುತ್ತೆ, 2 potassium inside ಬರುತ್ತೆ. And during polarized state, sodium and potassium voltage gated channels will be closed. Potential difference and develop ಆಗುತ್ತೆ when neurons are rest. That potential difference ಗೆ resting membrane potential ಅಂತ ಹೇಳ್ತಾರೆ. That is about minus 70 millivolt. Depolarized state ಅಲ್ಲಿ ನಾವೇನು ನೋಡ್ತೀವಿ, outside we see negative charge, inside we see positive charge, mainly because of opening of sodium voltage gated channels when in the area where stimulus is applied. Next, that stimulus will shift to adjacent area and previous area will become repolarized state by closing of sodium voltage gated channels and opening of potassium voltage gated channels. So, this is about how the generation and conduction of nerve impulse takes place. In the next class, we will discuss about synapses and types of synapses and properties of neurons. Thank you.